Hello everyone, welcome to our pre-calculus pre-recording video. So in this lesson we will discuss about solving systems of linear equations using matrices and application problems. We will discuss these are the agenda: review on row operation, review on row echelon form, then solving equations, application problems. This is a very important concepts because most of the math that we do here is by using the row operations. So this is important that we understand this concept. Interchange any two rows is allowed. So basically you can write row 1, row 2 interchange, that kind of thing, row 1, row 2 if you want to interchange between, say, here it is given this row, this row. So if you want, you can write 4 minus 1, then 2 first, then 1, 2, let's write 2 here, 1, 2, and 3 here. So if we want, we can interchange between row 1 and row 2. Okay, this way this is possible. Replace a row by any non-zero multiple of that row. That means we can multiply a row by any number we want except 0. Okay, so let's say if we want to multiply it by minus 2, then it will become minus 2, it will become minus 4, it will become minus 6. Let's say if we want, okay, you can choose any number and multiply it. And third number is replace a row by the sum of that row and a constant non-zero multiple of that some other row. This is like row 2, we are doing operation on row 2, and something we will do in row 1, then we will add it with row 2 when you are replacing row 2. Suppose if you are replacing row 3, then what should you do is you do something in the other row, then plus row 3. This is what they are saying. Or you can do it this way: row 3 equals to row 3, then plus something or minus something. You can do, or minus something also you can do here. Okay, but row 3 should be intact. We cannot change row 3. We cannot do anything in the row 3 when you are replacing the row 3. This is what it said. We will see, we'll try to apply these concepts in some application setup. This is the row echelon form. As you know, if diagonal element is 1 and everything below the diagonal elements are 0, this is called row echelon form. And in most cases, our target is to bring the maths into the row echelon form. And there is another one which is called reduced row echelon form, where this ABC also is 0. So we have a couple of maths here, and this is in this lesson also, as you can see, we will confine our concepts within 2 variable and 3 variable equations, but matrix row operation is true for any number of equations. Let's say 5 equations, 6 equations, 10 equations, it doesn't matter. Just the math becomes like notoriously bigger, So let's try to solve math from here. So let's have a look. Let's solve 60 number. This is the last one in this set, in this all the maths here. Usually last one is the hardest one, but not sure about this one. Let's see. So we have 3, 3, 1, and then 1. We are writing it in the augmented form. Then 1, 2, 1, 0. Then 2 minus 1, 1, 2 minus 1, 1. Then we have 4 here. 3, 3, 1, 0. 1, 2, 1, 0. This is 1. Okay. 2 minus 1, 1, 4. Okay. So all good. Now, our target is, always keep it in mind that the target is 1, 0, 0. Then here A, 1, 0. Then B, C, 1, and something, whatever it is. Suppose M, N, O. M and P, suppose something, whatever comes here doesn't matter, but our target is to go there. So first target is, our target is 1. We want a 1 there. How do we get that 1? So let's interchange this row because there is a 1 here, we can see. Okay, so 1 2 1 0, then 3 3 1 1, then 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 okay, let's write it. 2 minus 1 1 4. I was thinking if if I want to do any operation in the row 3, but let's keep it here. So what we have done here is we have interchanged row 1 and row 2, so you can write it like row 1 interchanged with row 2. Okay, this is what we have done here. This equals to so what can we do now here? So let's write the first line because we don't want to disturb the first line anymore. So what can we do here? We need a 0 here. Now our target shifted. Target is to get a 0 here. Okay, this is 0. So 3 minus 3 into row 1, if we do, then actually we get a 0 there. So it will become a 0. So what we are doing here, let me write first so that you all can get it. We are trying to do this row 2. Let's write it here. Row 2 equals to row 2 minus 3 row 1. This is what we are doing. Okay, 3 row 1. So this is 3 to the 6. 3 minus 6 equals to minus 3. This is 3 into 1 3. 1 minus 3 equals to minus 2. 3 into 0 means 0. 1, so it will remain 1. All right, and in the row 3 also we can target this 0 here. If we target that 0 here, then what can I do is we can multiply row 3. We can say that row 3, what is going on? Row 3 equals to row 3 minus 2 row 1. Okay, so it becomes 0. 2 into row 1, so this is minus 2, so minus 2, this is minus 4, minus 4, minus 1, minus 5. Then this is 2, 1 minus 2 equal to minus 1. This is 0, so 4 minus 0 equals to 4. So far good, because we got 2 0 here. Our next target is to get a 1 here. So 1 2 1 0. So how do we get a 1 here? This is a little bit funny about if we divide this line by 3 minus 3, then we get a 1 here, plus 1 here. So let's do it. Okay, let's do it. 0, this will become 1, this will become 2 by 3, this will become 1 by 3. Okay, we are dividing this row 2 equals to row 2 divided by minus 3, and we got the idea from this minus 3, because if we do it, then maybe there is easier something also to get this 1. But let's say this is also this looks straightforward. This looks straightforward because also sometimes we will try to avoid getting some fraction in our math, but sometimes it is unavoidable. If it is unavoidable in some maths, it is unavoidable. So we may have to bring it. Maybe not sure if it is true for this maths or not, but let's bring it, no problem, because we know how to work with the fraction. Then 0 here. Now I can do one thing, that is, okay, let's write this line here, because if I do it another operation, then it will confuse some of you, or it may seem confusing. Okay, just I have written the last line. I haven't done anything with this line. This equals to, so 1 2 1 0, then 0 1 2 by 3 1 by 3. Okay, so what I wanted to do in this last line is, because see, our target is to get a 0 here for 5. Okay, so how do we get that 0? We multiply the row 2 by 5 and add with row 3. Let me write it here. So what we are interested to do is here, row 3 equals to row 3 equals to row 3 plus 5 row 1. This is what we are trying to do here, and this will be this fraction number related, so be careful. First of all, first one will be 0 because 5 into 0 means 0, 0 plus 0 equal to 0. 5 into 1 means 5, then 5 minus 5 equal to 0. See, we have got that 0. That was our target. This 0 was our target here. Then 5 into this, 5 into this is 10. 10 divided by 3 minus 1. So 10 divided by 3 minus 1 equals to 7 by 3. Let's check again. 5 into this, 10. 10 by 3. 10 by 3 minus 1. So 10 minus LCM is 3. So 10 minus 3 equal to 7. 7 by 3. 7 by 3. Then multiply this by also 5. So it is 5 by 3 plus 4. 5 by 3 plus 4. So 5 by, is it 5 by, yes. 5 by 3 plus 4. Okay. 5 by 3 plus 4 equals to what? 5 divided by 3 plus 4, 12. 5 plus 12 equals to, did you miss anything here? Is there any sign or something? Okay, let's check. There is 0 minus 5. This comes 17 divided by 3. Let's see if we have missed anything somewhere. This is 2 minus 1, 1. 2 minus 1, 1, 4. Okay, no problem there. So this is 2 minus 1, 1, 4. No problem there. So from this line, we go there. This is row 3. This is minus 5. Then this is minus 1. 4 minus 0 equals to 4. So no problem as it seems. 5 minus 1, 4. Then we have, this is 1 by 3. Is this correct? This number? This is 1 by 3. This is 1. This is also 1. This is also 1. Oh, this number, right? Is this number is 1? Oh, this is 1 because we just interchanged it. So 0 minus 3, 1 minus, this is negative is on the other side, so it should remain 1. Oh my god, so we missed to give a minus here. Yeah, see, when we subtracted by minus 3, we did not give a minus here. Oh my god, that's why it is coming a little bit funny. So okay. All right, so it will be minus. Okay, it will be minus. So this is a minus. So it is basically 4 minus 5 by 3. Okay, so it is 3. 12 minus 5. 12 minus 5 equals to 7 by 3. So this is also 7 by 3. Now we got it. Things are going somewhere. So intuitively we understand that if something like this is not impossible to come, but this is kind of unusual. If something unusual happens, we should look for if we have made any mistake or not. Okay. So what we have here is 1, 2, 1, 0, 0, 1. This is 2 divided by 3. this is minus 1 by 3. Okay, minus 1 by 3. Minus 1 by 3. Then this is 0, this is 0, and divide the whole thing by 7 by 3, because this is 7 by 3, this is also 7 by 3. So this will become 1, this will also become 1. So what we have done in the last line is we have done row 3 equals to row 3 divided by 7 by 3. Then you get 1 and 1 here. And actually we got the solution here. This is our x line, this is our y line, this is our z line. So that means z equals to 1. That means z equals to 1. Z equals to 1. And we have, this is our y plus 2 by 3 of z. Y plus 2 by 3 of z equals to minus 1 by 3. Okay, so what is the value of y? So y equals to, z equal to already 1, so just send this number in the other side. So this is 1 by 3 minus 2 by 3. So basically this is minus 1. Okay, this is minus 1 because 3 3 common, 3 3 is same, minus 1 minus 2, that means minus 3. Minus 3 divided by 3 equal to minus 1. And then this, so x plus 2y plus z equals to 0. Okay, so x plus 2 into y means minus 1, z is 1 equal to 0. So you get x, this is minus 2 plus 1 equal to 0. So x minus 1 equal to 0. So x equals to 1. So our solution is x equals to 1, y equals to minus 1, z equal to plus 1. Okay, so our solution is this. And we can verify it. So our solution is x equals to 1, y equals to minus 1, and z equals to plus 1. So is this correct or not? How do you know? We will put it here. So first equation is 3x plus 3y plus z equals to 1. So 3 into x equal to 1 plus 3 into y equal to minus 1 plus z equals to 1 equal to 1. So this is 3 minus 3 plus 1 equals to 1. So this and this cancel out, 1 equals to 1. Proved. So this is correct. Now second equation. So second equation is x plus 2y plus z equals to 0. 1, 2 into minus 1 plus 1 equal to 0. So 1 minus 2 plus 1 equals to 0. So you see 2 minus 2 in this side and equal to 0, 0 equal to 0. Third equation, twice x minus y plus z equals to 4. So 2 into 1 minus 1 plus z equal to 1 equal to 4. So this is plus 1 actually. So 2 plus 1 plus 1 equal to 4. So 4 equal to 4. So this is also proved. So all three of them matches. You can say, sir, is it fine if we just prove one of the equation? No, it's not. We'll have to prove all of them. Okay, this value should match with all of them. Okay, and if the math is correct, you will see that actually all of them will match for sure. All right, so let's go to this kind of math. This is our application math. Adam and Michael require an additional this dollar annual income beyond their pension benefits. They rather are risk averse and have narrowed their investment choice down to treasury notes that yield 3%, treasury bonds that yield 5%, or corporate bonds that yield 6%. If they have $600,000 to invest and want the amount invested in the treasury notes to equal the total amount invested in the treasury bonds and corporate bonds, how much they should place in each investment? So this is the question. So for this question, we first look. First of all, we have total amount of investment is how much? 600,000. This is the money that they have. Okay, these two guys. And this is the amount that they want their profit. Okay, their profit or the interest or the benefits. This is what they want to make. So first of all, there are three types. One is treasury notes, treasury bonds, corporate bonds. So total amount is 600,000. Now, from the treasury notes, they want to invest 3%. 3% treasury notes. 5% treasury bonds. That's why 0.05. 5 divided by percent. Percent means divided by 100. This is equal to 0.05. Okay, this is how 0.05 comes, 0.06 comes, this equal to this. So this is the equation number 2. Now for equation number 3, how it comes. This is very, this one is little bit annoying. If you shuffle it, then it becomes n equal to b plus c. This comes from the third condition, last condition. They said that treasury notes equal to the total amount invested in treasury bonds and corporate bonds. Treasury bonds and corporate bonds. So treasury bonds and corporate bonds total equal to treasury notes. So if you arrange it, then it becomes equal to this. So this is the last line. Why do we arrange it this way? The reason is, if the equation you have in this format, then you can solve it. How do we solve it? Let me show you. This way. So first 1, 1, 1. We just write it in the augmented form. Okay. Then this one, this is 0.03. So multiply this by 0.03 first line and then subtract it from the row 2. So row 2, this is row 2 minus 0.03 of row 1. Then we get this line. And then row 2. This is actually a mistake here in the book. This math is taken from the book. This will be row 3. Okay, this will be row 3. This is a mistake in the book. So this will be row 3, not row 2. Okay, then you get this line, and then we continue by following this operation. We get the solution. This is basically the row operation kind of thing. We have another similar type of maths there. We will explain it a bit more. Just the row operation, just the same thing that we have done in our previous maths. Similar kind of operation here it goes, but since it is an application math, the numbers are a little bit bigger. So we will have to just deal with it. That's it. Nothing much. This is another math. Charlotte has a $10,000 to invest as her financial, I think this A will be capital letter, as her financial consultant. He recommended that she invest in treasury bills that yields 6%, treasury bonds that yields 7%, and corporate bonds that yields 8%. Charlotte wants to have an annual income of $680, and the amount invested in the corporate bond must be half that. This is the third condition, that invested in the treasury bills. Find out the amount in each investment. So first of all, again, something like this. Total amount of money that she has is $10,000. So that is the total amount of investment that she can do. This is $10,000. This is the amount of profit that she wants to make. And the percentage that she wants to invest is 6%, 7%, and 8%. So 6% becomes 0.06, 7% becomes 0.07, 8% becomes 0.08. XYZ is their relative item name. Okay. And last condition, this becomes z equals to 0.05, which comes from this line. The amount invested in corporate bonds. Okay, corporate bonds. So corporate bond is the last one, 8%. That's why z. Corporate bonds equals to half. See, half that she invested in treasury bills. Treasury bills is the first one. 6%. See, treasury bills yield 6%. Treasury bills is the first one, so it is x. So half, this means actually 0.5x, and if you bring it one side, then it will become 0.5x minus z equal to 0, which looks like this. Or you can write z minus 0.05x equals to 0 also. You will get the same answer. Okay. So we have this, and then this is the this is written in the row augmented matrix. And if you want to solve it, what can you do is, let me a little bit help you, so that you have 1, 1, 1 in the first line, 10,000 here. The target is this. Your target is this. So you multiply the first line by 0.06 and subtract it from row 2. So what you do is row 2 equals to row 2 minus 0.06 of row 1. Okay, this is what you are going to do. So 0.06 minus 0.06 equal to 0. 0.07 minus 0.06 equals to 0.01. Then 0.08 minus 0.06 equals to 0.02. And then this equals to 680 minus 680 minus. I think that will be 600. 600, and then that will be 610,000 into 0.06, 600. So 600 minus 680 minus 600 equals to 80. Then you have, oh, let's multiply this then by 2 so that this 0.5 becomes 1, so that we can later make it 0, because that is our target. Then it becomes 0, it becomes minus 2. Oh my god, my machine is crazy. So this is 0. We multiplied row 3 equals to 2 into row 3. This we can do because they said that we can multiply by any non-zero thing to a row. Okay, so we can do that. I really wish that this video will not be lost. So what can I do is 1 1 1. I recorded it one time yesterday also, but for some reason after I finished all these things, the entire video, then I have found, then when I stopped the recording and then I played it, it's like just only 8 minutes is recorded, the remaining thing is not there. I was like, what happened with the other part? And unfortunately computer cannot talk, so I cannot ask the computer like, what happened, tell me, what did you do with my rest of the video? Computer cannot tell it. This is funny. So what can we do here is, look, we need a 1 here, so just divide this line by 0.01. Okay, so this will be like 0, this will be 1, this will be 2, and 0.01, if we divide it here, then it will become 8,000. Okay, and then what can we do is we can subtract, which one is better? Let's do it. Okay, we can subtract from row 3 minus row 1. So it becomes 0, it becomes minus 1, it becomes minus 3, it becomes minus 10,000. So what we have done here is we multiplied, we divided. So row 2 equals to row 2 divided by 0.01. This is what we have done. And for row 3, what we have done is row 3 equals to row 3 minus row 1. This is what we have done here. Then what can we do is 1 1 1. This is 10,000 here. So yeah, our second line is actually no problem. We already have something here in the second line, so no problem with that. And the last line, what we want here is we want to make a 0 here, right? So how do we make a 0? We add with the second line. So this and this 0, this and this 0, this and this minus 1, this and this minus 2,000. You understand? So what we have done here is row 3 equals to row 3 plus row 2. This is what we have done here. And actually now you can see the solution. If you multiply by a minus 1 last time, then you get z equal to 2000. So already you have the solution. If you get z equal to 2000, you can get x equals to what? Then if you get x and y equal to what, you can get the other things. Okay, everything now you can get already. Just next line you will get the answer. Multiply this last line R3 equals to minus R3. Multiply by minus sign, then you will start getting the solutions. I think I will not have to do anything more from here. So this is how we solve the real-life application maths by using the matrices. When you have this kind of situation, you just make it some equation, and then just solve it by using row echelon, by using the row operation. Why do we use this matrix operation, this row echelon form or row operation? The process is algorithmic. Okay, that is, it consists of repeating steps that can be programmed on a computer. The process works on any system of linear equations, no matter how many equations or variables is present. What is it? What we mean by is this thing. You can tell the computer row 2 equals to this into this into this. You can tell the computer will understand it. This operation, computer understand it because this is just a command. Row 2 equals to 1 divided by 0.02 of R2. So computer can just do it. Whenever you ask the computer to do it, computer will automatically do and do all the calculation. Computer will do all the calculation and they will show you the result. Just you give a command, then computer will like, okay, this is the answer. You then again you write a command line, then computer like, okay, this is the answer. So you can tell the computer what to do in this kind of case. And 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 this is useful for any system of linear equations, any number of variables. Do you understand? This sentence, this second point is so strong. This is very strong because it says that you can work with any number of systems of equation. Do you understand? Like we have worked with 3 lines, right? Do you understand? This is 3 lines. 3 lines. If it is 5 lines, 10 lines, this row operation works for them also. So if it is 10 lines, this will be very hard for you to solve the math by the conventional methods, but row operation will help you much. This is why this row operation is so important. Okay, that's all for today. Thank you all. Thank you very much. Have a good day, everyone.